Starting today, so we've done parallelograms, right? We talked about parallelograms. Parallelogram was one of the quadrilaterals that we are going to be looking at in this chapter. And starting today, we are going to do a different shape every day. The first of those is a rectangle. So this is the official definition of a rectangle. This is what can go in like a reason column for the proof, right? So the definition of a rectangle is that it's a quadrilateral with 4 right angles. I know if I ask you, just in general, hey, what is a rectangle? You'll tell me all sorts of things about a rectangle. But the official definition is it's a quadrilateral with 4 right angles. So now, the question here is a rectangle a parallelogram?
Yeah.
Going by the definition, why? Julian, why? Okay, so we definitely know if it has 4 right angles, the opposite angles are congruent. And that's enough. That's a theorem. That's enough for it to say that it's a parallelogram. Yeah.
Well,
yeah.
Well, there's the supplementary here.
Right.
And then there's also the congruent sides.
Okay, so the congruent sides, it's not immediately obvious, right?
It's not obvious, but like it kind of has to be because of the 90 degrees.
Right. Yes. Because when they're all 90 degrees, these lines are also what to each other?
Parallel.
They're also parallel to each other, right? Yeah.
Can that also be a square quadrilateral for right? Yes.
Yep. So right now we were just saying, is it a parallelogram? And it is. And yes, it does relate to a square as well, right? Because a square is also. But what additional condition is there for a square? All sides are also congruent. Okay, good. Yes.
Isn't there like the thing that's kind of like if there's like 1 right angle in the parallelogram and there's 4 right angles?
No, that's for perpendicular lines. If you have 2 perpendicular lines, if there's 1 right angle, then there are 4. Right. So if you have 2 lines that are perpendicular, if there is one right angle, then there must be 4. That's what the theorem says. However, you can have a parallelogram with you can have a quadrilateral with only 1 right angle. Okay? All right. So, moving along. So, a rectangle is a parallelogram. We just established that. So the next question, do all of the properties of parallelograms also apply to all rectangles? Yes. 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 So all of those properties of the parallelograms that we talked about here, all of these apply to the rectangle. Okay? No, well, yeah, these are all applied. There are going to be some that are just specific to rectangles, but all of those also apply, okay? Okay, so here's a theorem now. This is something new. The theorem says, if a parallelogram is a rectangle, then the diagonals are congruent. Okay, so because a rectangle is a parallelogram, we already knew that the diagonals bisect each other, but now we also know that they're congruent to each other, okay? So if you want to abbreviate it, you can say a rectangle applies that the diagonals are congruent to each other. Okay, so let's prove this. We are given rectangle ABCD. Do you see the difference between the shape, like the symbol for the rectangle and the parallelogram? That was a little bit more swayed. So this is rectangle ABCD. Okay, so I know sometimes we run out of room here, right? So for this one, start from, further to the left. Huh? You can do the shape. I wrote out rectangle just so later when you go back to the notes, you recognize that that meant rectangle. Okay, so that's the given. Okay, we want to prove AC is congruent to BD. Okay, so those aren't even shown, but I'm going to draw them. So we want to prove that AC is congruent to BD. So BD and AC. Okay? All right. So the way in which we can do this is, do you see how there are two major triangles here? One is this side, B, C, and then onto D with this blue diagonal. That's one rectangle, right? This big one. And then another one is with the green, here, 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 okay? So we want to prove that those two are congruent, and when we do that, we can prove by CP/CTC that the green and the blue are congruent. So let's get started, and then I'll take some questions in a minute. So, since we know that a rectangle is a parallelogram, you can say that AD is congruent to BC. Okay? Because it's a parallelogram, so all of the rules apply. So you can say a parallelogram implies opposite sides are congruent. Okay? So it's established that a rectangle is also a parallelogram. You don't have to like restate that. Yes? AB and DC, yeah, but see, what I'm doing is I want to show this triangle, right, is congruent to that triangle. So this is going to be left out of what I'm doing. Okay. Yeah. Okay. Julian, question or?
Yeah, can you just diagonal separate parallelogram?
Well, no, because that's not exactly what we're huh?
Because it's not
Yeah.
they're overlapping.
Yeah. Because this is not like these diagonals are different diagonals, right? That's what. Okay, so let's do a couple and then I'll take more questions, okay? So number 3, we want to say DC is congruent to DC. So basically look at the two triangles that we have here. It's this one. Let me write it here. Hang on, Elijah. It's this one and then this one. Okay, so those are the two that we're looking at. So this is DC for both of them. So we want to say DC is congruent to DC, and that's reflexive. Okay. Now, angle ADC, this one, and angle BCD, this one, so on these rectangles, on these triangles, it will be these, are both right angles, right? So we want to say angle ADC and angle BCD are right angles. And that is the definition of rectangles. Okay? Now, if those two are right angles, then we know that they're congruent to each other, right? Angle ADC is congruent to angle BCD. Right angles are congruent. Okay? So let's recap. What have we done so far? We've shown that these two sides are congruent. We've shown that these two sides are congruent. We just showed that those right angles are congruent. So now I can say that the triangles are congruent by SAS, right? So where are the triangles that we're talking about? This is one triangle, ADC, is congruent to. Another triangle is, let me do it in the black here, BCD. Okay? SAS. Huh? Right angles are congruent. All right angles are congruent. So now that I've proven that the yellow and the black triangle are congruent, I can say that the hypotenuse of one is congruent to the hypotenuse of the other. So number 7 is AC is congruent to BD, CPCTC. Okay? So this is why that triangle chapter is so important, because you see how in every proof, right, those like proving triangles congruent just sort of creeps in. Yeah? Okay. Okay, so take a look. Yeah. Okay, very quickly, because I need to move on.
For the second one, would it be parallelogram or would it be rectangle?
No, it's a parallelogram. I know that AD is congruent to BC because opposite sides of a parallelogram are congruent. That's the theorem. And I can apply it to this because I know that a rectangle is a parallelogram. There is no theorem that says opposite angles of a rectangle are congruent. Okay. Here we go. Quadrilateral ABCD is a rectangle. So immediately when you know that it's a rectangle, you know all 4 right angles, diagonals are congruent, and you know all of the stuff from parallelograms. Okay. If AC is 30 minus x and BD is 4x minus 60, find the value of x. Well, what do we know about AC and BD? Congruent. So set them equal to each other and go ahead and find x. Okay. So, how did that work? So what's x? 18. Fabulous. Okay. MNQR is a rectangle. If NR is 2x plus 10 and NP, okay, so NP is just this one, 2x minus 30. And then NR is 2x plus 10. So this whole thing is 2x plus 10. How are we going to set this up? Yeah, go ahead. Right, so you can either do 2 times 2x minus 30 is equal to 2x plus 10. Or, no, hang on. Or you can say 2x minus 30 is half of 2x plus 10. And now that we're in second semester geometry honors, we're like pre-algebra 2 students, you know, you're free to choose which one you feel is best, right? So go ahead and solve. What do we get for x here? X is 35. And then MP, so MP is, so 2 times 35 minus 30 is 40. Okay, so MP is this one, right? That's one that we didn't have any information on, but we know that the diagonals are congruent. And we know that the diagonals bisect each other. So we know that all 4 of these little bits are congruent to each other. Okay? Okay, so take a look at the next one. Quadrilateral ABCD is a rectangle. Find the value of x and y. Okay, so if it's a rectangle, what do we know? Madeline, what do we know?
That all of the sides are right.
All of the angles are right angles, right? So this one is a right angle, meaning 4x plus 9x plus 12 is 90. 13x is 78. X is 6. Okay. What am I going to do about the y's? Yeah.
You set them equal to each other.
Why? Why do we know that they're equal to each other?
Well, because we know that the sides are parallel. And
Uh-huh.
So we can just say the diagonal is a transversal, and then we like set y squared plus 4y plus 5, and we set that all equals 0.
Right, so y squared minus 1 equals 4y plus 4. And go ahead and solve that, and I'll walk around
So
and
we can,
look
we
at
can
your
also do it like
y.
y2 minus 1 plus 4y minus
Y squared minus 4y minus 5 is equal to 0. So how do we factor?
I don't find a negative 1.
Yes. Y minus 5, y plus 1 equals 0. Y equals 5, y equals minus 1. Okay, now, do both of these work?
No.
No, the 5 works, but the minus 1, if you plug it in here, you got minus 4 plus 4, 0 degree angle. That doesn't work. Okay, yeah.
Why is it plus 1?
So you want two numbers that multiply to negative 5.
Yeah.
So that's negative 5 times 1. And then they need to add to negative 4.
Oh, I did the opposite way.
Yeah.
I subtracted y squared as
Oh.
1.
But do you see?
Yeah.
Okay, awesome. Okay, yes. PQRS as a rectangle. We want to find each angle measure if angle 1 is equal to 40. Okay, so we're going to do something very similar to what Rihanna was doing as well, right? So if that's 40, how much is angle 2? 50. And then, alternate interior angles. So angle 6 is also 40, right? And angle 5 is also 40 because of what we just said. Those are all isosceles triangles over there. So that makes angle 3 50. And that makes angle 4 in this little triangle 80. And that makes angle 7 100. And, my battery's running low. And that makes what?
40.
So this is 40 and this is 50. I love these. These are so much fun. I could do them like all day, right? So we can fill these in, right? So angle 1 is 40, then 50, 50, 80, and then angle 5 is 40, 40, 100, 50. So we did that kind of quickly. Any questions?
I do.
Yeah.
I don't understand like the isosceles thing.
Okay, so you know that the diagonals are congruent. So this entire diagonal is equal to this entire diagonal. Okay? We also know that the diagonals bisect each other. So that means this is congruent to that, right? And this is congruent to that, correct? But if the entire blue is equal to the entire red, then half of the blue is equal to half of the red, right?
Yeah.
So this is also, they're congruent like that. So that makes that triangle isosceles. All the triangles inside are isosceles. Okay, so last but not least, here's another theorem because we haven't had enough theorems in this chapter yet, right? Okay. Okay, so if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Sounds like a converse, right? This sounds like a converse of the one we just did. So before we had heard, or we had read, that if a parallelogram is a rectangle, then the diagonals are congruent. Well, the converse is if the diagonals are congruent, then the parallelogram is a rectangle. This is a converse of the one from the beginning, okay? So, abbreviation looks like this. If the diagonals of a parallelogram are congruent, it applies that it's a rectangle. Okay, Leah, did you have a question?
One to know is when we're doing tests and we have like the list, I just gonna write out the abbreviation.
You can totally do the, yeah.
Are the abbreviations gonna be on the list?
So these you have to know.
Like we have to memorize
Yeah.
them all?
Yeah.
They're not gonna write them out?
No, because they also, yeah. Okay. So, yeah. These are ones you have to memorize, unfortunately. Okay, so let's do this. I like to always graph these. Huh? This one, I would. So we have D is -4, comma -1.
I have the post-it notes I can use.
So it doesn't have to be super exact, but I like to do it because, you know, like you want to see the orientation, okay? Then F is -2, comma -5. 4, 5. G is 4, comma -2. So we're kind of doing this sort of like scratch work, okay? So this is G. And then H is 2, comma 2. Okay, so Elijah, okay, so that's how it looks. And the question is, what is the question here? The question is, determine whether DFGH is a rectangle given each set of vertices. So, to show that it was a parallelogram, okay? Okay, so to show that it was a parallelogram, what we did is we found the slope of these opposite sides and they had to be the same, right? Now, to show that it's a rectangle, not only, so DF and GH has to have the same slope, and DH and FG has to have the same slope, but in addition, how should those slopes relate to each other? Because those are 90-degree angles, the slopes have to be perpendicular the slopes, right? They have to be like the negative reciprocal, okay? So you have two options here. One is find slopes, okay? And you have to, and so the slopes, not only do the parallel ones, not only do the opposite ones have to be the same, but they have to be the negative reciprocal of the adjacent one. Is that making sense to you guys? Yeah? Huh? No? Yes? Yes? So for example, if this has a slope of -1/3, this has to have a slope of -1/3. But these two has to have the same slope here, but they have to be the negative reciprocal. So it has to be +3/1, +3/1. That's one way, okay? Another way is the following. You have to do the distance formula. It's not that bad. And in fact, that's what I'm going to do right now because we all need practice with the distance formula. You have to find distance of diagonals. And if the diagonals are congruent, then it means that it's a rectangle. Since we just did this proof, since we just did this theorem, let's do the distance of the diagonals, okay? So let's do the length of the diagonals. So what I want to do is I want to find DG. Let me do it in different colors. Let's find distance DG, okay? So that's going to be the square root of, okay, so D and G. Even at this age, when I do this, I like to mark them because sometimes we get distracted and we get confused, right? So x2 minus x1, 4 minus -4, so that's 4 plus 4 squared, plus y2 minus y1, -2 plus 1 squared. This is going to be the square root of 64 plus 1, square root of 65, so DG is root 65. Okay, so that's DG right there. Okay. Next, I want to do FH. So FH is this one and this one. So this is the square root of x2 minus x1, 2 minus negative 2, 2 plus 2 squared, plus y2 minus y1, 2 plus 5 squared. Okay? So what is that? 4 squared is 16 plus 49. Is that 65? Yay! So yes, it's a rectangle. Okay? So you can say therefore. Okay, so look at this. Do you guys know the symbol means therefore?
No.
Okay, it's 3 dots in the shape of a rectangle. In math means therefore.
Wait. Triangle.
What did I say?
Rectangle.
Sorry. 3 dots in the shape of a triangle means therefore. So therefore, what is it? What was the letters? DFGH is a rectangle. Okay, let's quickly do the slopes here, just for fun. What's the slope of DH? It's 1/2. Okay, Clara says it's 1/2. I'm sorry. Sorry. Remember triangle, rectangle?
Yep.
I'm 1 over today. Okay. What's FG?
Also 1/2.
Also 1/2. Okay. What's DF?
I did it already.
Guess who found the slopes? And what's GH?
-2.
Okay, so take a look. Opposite ones are the same. Opposite ones are the same. That means it's a parallelogram. But in addition, if the 2 consecutive ones are negative reciprocals of each other, then they're perpendicular slopes. Cool?
Got it.
Got it. Okay. So, homework then.